All right. That doesn't work. All right. Tonight's talk is about working with API data, and I think a lot of you might have already done that in the past. So it's probably nothing completely new, but I think there's like several ways of doing so, and I just want to show a few patterns that you could use and what are the advantages and disadvantages, and in which cases to use them. And so I'm basically going to structure it in the first part is going to be a little bit more about theory and the concepts, and the second part is an actual application that shows a couple of those patterns in action. So on the client side, we have API calls that require user information. So anytime you require a login, also a cookie or session token to be present to access a certain service, and the user needs to log into that service, so you as a provider of a website or an app, you don't actually have their credentials, then you need that. And sometimes there's also cases where you might have a limit on how many API calls you can make, especially if it's a public API, in which case you can also try to let the clients do the API calls so that you don't run into any limits, because basically every client makes the requests for themselves. On the server side, you get a lot more security. You have full control over what kind of API calls are made. You can make validations on the data that is requested, or even filter out stuff from the response to only return what you really need. And there's two different mechanisms here, I think. One is regular polling from the server side. You would usually do that in when you have a static data set that you just want to update on a regular basis. And the other one is custom queries, where you let the user and the UI decide what the information they want, then you tunnel it through to the server side, make any manipulation to the HTTP request to the target API, add credentials, authentication, or any additional payload that you might have to retrieve, and then you return the response to the client. So let's look at the client side first. One of the bigger issues on the client side is cross-site scripting, and some of you might have encountered that problem. You're trying to access a separate, an external web service, and suddenly you get cross-site scripting error in your Chrome console, and it doesn't work. So for that, you need something called browser policy. So there's a server-side package in Meteor for that. And this is actually, it's tricky to get the right directives together, and the topic is not that well documented. So it sometimes comes down to a little bit of try and error and see which patterns match. So I think that one is one of them that works for any port on any of those subdomains. What basically happens now is that when a client comes and requests to see the front end, the server will return this directive in the HTTP response header. And that will allow you to basically access any API on the specified subdomain, but it will disallow you to use any other external API. It would just bring up the cross-site scripting error. And here's a little bit of code how to do that. I hope it's big enough to read. The first element that we have here is a reactive variable. Basically, as soon as the HTTP request to the API comes back, you set the content of that reactive variable, which in turn will re-execute the helper. So this is the helper that you call from the template. Could return an array or a single object, depends on your functionality in the template. And so this helper is executed twice once invoked. The first time, obviously the content of that variable is undefined, which means the HTTP call is executed asynchronous, and at the same time it returns undefined. You can play a little bit with the if condition and add an else block to return some default value of false or an empty array, depending on your template functionality. And then once the HTTP call comes back, a little bit after that has been returned, it will update this reactive variable, and that will lead to re-execution because we're accessing it here, and this time it won't be undefined, it will directly return the result of the API call that's stored in the variable. And this is the basic pattern that I would recommend for well, basically all the client-side functionality. When I get to the example, I will show mostly the server-side. And this is kind of like the core pattern that repeats with slight variations, obviously. So let's have a look at the server side now. The first case is server-side polling. So I found that when you have a static data set, so for instance, the stock price or the weather forecast for a specified location that you want to embed into your app, then it's not really clever to let every client request the same data again and again, especially if it doesn't have to be up to date all the time. Sometimes it's enough to see, okay, every 2 hours I update my data set, and that's it. At this point, sync cron job would work fine, and you can basically replicate the result of the API call, provided it's not too big, into a Mongo collection, and then use the standard Meteor patterns. So basically, you have a sync job on the server side, which polls on a specified interval, so the documentation for that package is actually very good, and it's relatively easy to use. You can specify which polling interval in like every 2 hours or every 12 hours, every 24 hours, whatever your use case requires. And then you replicate that API data into a Mongo collection basically by overwriting it every single time. And then the client can just subscribe to the published content. Yeah. On the other side, we have those custom queries, which basically operate similar to client-side request, where you query an external service, although in this case, we just query the Meteor server as our data source. And the server-side method can then handle any external communication. The advantages of that is you have a lot of security where never trust the client, so the client sends some bad request or so, you can filter it out in your method on the server side where the client can't manipulate anymore. And you can also make sure that the client is actually allowed to see the data, which means that permission checks. Additionally, you have the ability to cache. Now, you could again use a Mongo collection, although then that would be more like the first case scenario. Another method to cache would just be on the server side a variable that holds a certain cache, like a map of items. So next, I want to get to the example, which provided a GitHub link here, and I add that to the comments in the meetup as well. And so basically, what I built here is a little example app. It's actually using Meteor 1.3, my first go at it. And you can already see in the background some console messages telling me about retrieving auto reload. Get to that in a second. This one is basically pulling data from another data source. It's a service that runs on the same machine here. And but it's basically all data retrieved from the API. So these are 3 different entries. And so look, that's the management interface for it. So those are my 3 entries, and they appear here in my app now. And they are basically loaded at the beginning when the page is loaded, when the helper is executed the first time. And yeah, so that would be the template helper. And I recommend fetching the data in a function, because that way you can always reuse it and call it from events, for instance, when you click on an update, when you want to update the data or refresh it. And here we have the Meteor call, which is the same as our HTTP call on the normal client-side scenario, and we are calling a method which will return us the list of those elements that are displayed. And we store that in this reactive variable in our helper. Basically just looks if the variable is undefined. If yes, then catch the data and then return it. Yeah, so that's a very simple case, and it looks very similar to the standard client-side pattern. And this can't be any simpler than that. It's just a base URL. This way, in this example, it points to my local host. And the nice thing about the server side and the HTTP package here is that you can actually use it synchronously. So that makes it a lot easier than handling the futures yourself. So that's really nice to have. And then obviously you can enrich the request, you can add headers or data, and you can do more with the response here at this point. So that's the hook where you can add additional functionality. And if you have a parameter, it's the same thing, but I get to that example in a little bit. Now, obviously, sometimes you have people who stay on the same page, especially if it's a collaboration platform or so, and you want them to be able to reload the data. And so we see there, we get to the autoreload in a second. I put a refresh button here, which basically just a simple event, and you can see down here that it reloaded the data on demand, and every time I click it, it will come up again. And if I change the data in the backend now, that would come up here as well. Quickly getting into the code. Oh God. Reload. Okay, how does that work? Basically, the only difference here is the event. So that is my reload button, and what I call here is just refresh get data, and it's the same function as before. Now, basically, what happens here, every time I call that, it will retrieve the data from the server again, and then set it into the set this reactive variable, which in turn will re-execute that helper which uses it. So that's kind of the mechanism how the reactive variables work. So yeah, and to quickly get to the auto reload, because obviously you don't want the users always do them themselves. I put some slide on here where we can change the interval. So right now it's set to 5 seconds, and this token here, I'll show that in the code right now in a second what that means, but we can basically reduce it to 1 second, and now it comes up a lot quicker every second. And the only problem here is that sometimes people encounter that the events overlap. So here right now, the 1 second interval refresh has stopped and a new one has started. And there's a very, well, relatively simple way to do that. So I have a little bit more here now. So I obviously have the interval, which I want to configure. I use a reactive variable for that as well, and I default it to 5. And I have a token, and the token basically represents the origin of the trigger of the refresh, of the constant refresh. And if you look at the refresh function now, it actually has this token as a parameter, and that token is checked against whatever is stored in this reactive variable. And in my case here, I'm using a timestamp to do so. And that basically means that whenever the helper is invoked, so when you come to the page the first time, it will invoke it and refresh it with the timestamp when you open the website. Now, if I change the reload interval, what I basically do is I create a new timestamp and I set the current token to this new timestamp, which in turn will terminate the first execution of that function here, which means it's no longer refreshing, and at the same time I call the function with the new timestamp, which then will continue to reload automatically in the specified interval. And yeah, the helper itself is pretty much the same as for all the other methods. And the last case is, say, I mean, this was all very nice, you know, fetching lists of items, but what if you have a parameter that specifies a specific item that you might pick from a list? So this list here is actually populated from the content of that template that comes from this button here. So it uses the same here. And now what happens if I click on one of them, I basically want to retrieve, I make an API call with a parameter, and this is just a unique ID that comes out of it. And at the same time, I can obviously switch that, and then the data updates here as well. Now, interesting, if you watch it now, we requested the February and March, but if I switch between them, it doesn't refresh them. And I'll show you why. We're caching them on the client, where now our API data reactive variable is now a JSON object that can basically hold multiple entries. So I can easily switch between them without fetching them every single time. And so this is a little bit more complicated example now, where when we switch, we basically set the current parameter to whatever I selected, which is the unique ID. And then we execute a different method call, a Meteor call, a different method with this specified parameter that comes from the reactive variable. And finally, we update the content of the API data with this new data that we retrieved from the method call. And finally, overwrite the API data, the complete, basically the complete list of items that are fetched so far. And yeah, with this call, we're basically just selecting the parameter from the data object, which is the reactive variable that holds the data. And now to see that how that all works out, we're going to do is now create a new item here. Let's call it, what's next month's May? Meteor Meetup 29. Oops. And this is the description. Okay. Now, I haven't refreshed anything. This hasn't updated because it doesn't have any refresh functionality. This hasn't updated yet because I haven't clicked it yet. This has updated, so it has the new entry here because it updates every, well, right now, 10 seconds. And here, well, we don't have it either because the data comes from this one here. If I refresh here, it comes in, and well, to get it on the last page, we actually have to reload, which will just reset the memory and reload everything, and then we can select this new one that I just created as well. Yeah, so that example app is available on GitHub. So I created a little repository here, and I'm gonna add documentation to all the code, explaining the mechanisms, and probably will also provide the application that actually provides the data, so you can play around a little bit with yourself, by yourself. Yeah, and that's it. Yeah. Any questions?
Yeah. Yeah. So, I mean, I'm still pretty new to developing, just generally using JavaScript as a serious language. Up until now, JavaScript's just been that funny language that makes things animate and change. So I've been grappling with the event loop. So when you said you could make the HTTP call synchronously, I was like,
on the server side only.
On the server side.
Yeah.
So that doesn't hold up operations because.
Well, that particular thread, yes. So
yes.
If you make a call to a Meteor method,
yeah,
then there's basically a new thread. They call it fibers.
Yeah.
A new fiber that runs as long as the method call runs. Now, if you make an HTTP request, usually you need that response to do something with that, and then the method call returns some computed result, which is a result of the API call data and maybe something else. And there's a mechanism how to do that with using futures, where basically at the end of the Meteor method you return future.wait, as wait is the function, and that will basically hold the return until the asynchronous call in the middle comes back, and basically it sets this future that you return at the end to future.return, and then whatever you want to return. But it's a little bit tricky to use that, and that's why the synchronous wrapper is so nice to have, but that's only on the server side.
One question. I'm not sure how they work, but have you thought about packaging it up into a module or something? You know what I mean?
In general, this pattern.
Yeah. Because it's
I'm not sure. So I haven't thought about it. I would have to think about it, but I reckon that. So as you see those different patterns that I showed with how to reload and how to select sub elements and so, you can also combine them And I think the problem is, at some point, the refresh function could have a token and a refresh interval, or could have more and more parameter depending on how complex your query in the UI is. And I think that's something could probably be generalized, but not entirely sure.
Right.
So we'd have to think about that. Yeah, maybe not too bad of an idea. Yeah.
Sorry, just another question going back to the old event loop. Been on my mind. Probably. So let's say you have the scenario where you go off and fetch, a large static data set. You want to update the collection. So
Yes.
what was the
On the server side.
on the server
Yeah.
side? Yeah. So, I mean, is there any sort of advice or any sort of pattern that you could suggest for doing that?
Oh yeah. So there's as I mentioned, there's a package called. I think I had it this afternoon. Called it Synchron. There it is.
Yeah, because I'm using Percolate to go and do the fetch, but then I need to do some transformation on the data that's coming back.
Well, but you can put that all in your job function. So.
All right.
This is the job. Sorry. This is how you would do it. So you add a new job with a name and a schedule. The schedule specifies, for instance, here every 2 hours, and this is your job function, and that gets executed every 2 hours. And here you can obviously access everything like MongoDB, or you can declare a variable here that you access. Or yeah.
All right.
So we might have time for just one more question,
Yeah.
and then pizza's really
There's one.
good.
Any more questions? They're all hungry. All right, thank you.